Hey, welcome back to TSS Garage. I'm Zach Chrisman. Today we're going to take a look at the Hofmann 7100 through 7800 series of weight class balancers. Today we're going to focus on the 72, 4, and 600 series, and let's take a look and see what they have to offer. Today we're going to start off with the 7200S. Before we get going with talking about the machine, how it works, the user interface, I really want to dive into proper tooling selection and why it's important. I'm going to use this lighter passenger car wheel as an example. Generally speaking, we want to take a wheel assembly and we want to cone or collet it from the rear. It's not usually recommended to grab a machine interface from the front simply because that's not how it goes on the vehicle. If you can see inside of here, there's actually a machined lip that accepts the hubcap, and that's not the machine center line of the wheel. And that's one of the reasons we want to look out for that. The second, we want to deal with something that's low taper. Low taper allows us to ramp up to center much more quickly than something that's got a high taper to it, such as a standard cone. Standard cones can often lead to a slow ramp up speed, which allows two converging angles to get pinched off, if you will, before when too much torque is applied to the wheel before the wheel has hit the backrest or found center. This can often lead to a user chasing weight or wildly inaccurate centering of the wheel assembly and lead to someone questioning their results. So just make sure that we're using good practices here and using collets when necessary, possibly a pin plate instead of a pressure cup, and trying to apply those principles as often as we can. Let's go ahead and tool this up and start taking a look at the machine. It may be necessary to use a spacer when using a smaller collet so that we don't get the small area of the collet pinched up inside the collar. We're gonna go ahead, use the standard collet, put it on there. We have our pressure cup here. Our pressure cup has a rubber protection ring on it. This is gonna be the preferred method when using a pressure cup with anything painted or alloy. If we just had a standard steel wheel, such as a trailer tire or a spare wheel, something like that, we would use just the plastic. That way we're not embedding any metal particulate into this ring and causing damage to further assemblies later down the road. There's a brake pedal down here that allows you to limit the shaft. Once you get that on the backing plate, give it a snug up. No reason for it to be King Kong tight. We just want to make sure that it's not going to slip on there when the machine is under a braking or an initial spin load. Home screen on the machine basically has this wheel. If we're inside of a weight screen, we can always get back to the home screen by simply hitting escape. From the home screen, we have basically go right into putting in our dimensional data for this application. There's really a few choices here. If I had a standard steel wheel, there's only one thing we need to do, and that would be to grab our SAPE arm, which is the semi-automatic parameter entry, and we're going to touch the inside weight flange area there on the lip, and the machine's automatically going to see the diameter, the distance this circle starts. The third data point, which is the outside flange weight, is going to be acquired by the sonar. So as I close the hood, it's going to acquire that third dimension and it'll do its initial spin. The second parameter entry that you may choose is some type of a sticky weight, whether that's a nail-on weight on the inside, sticky weight on the outside, or sticky on both. We would take our SAPE arm and simply touch where we want the counterweight to go. This is one of the things where users often start to interchange maybe other styles of machines or other user interfaces that they've used in the past, and this is where things become a little bit cloudy as going from machine to machine. They all have a little bit of a different idiosyncrasies. It's important to understand your machine you're using so that you're on the same page as the data you're inputting into the machine. We all want to get good results, so let's make sure that we're understanding how the data is captured, what you're supposed to do with that data. We're going to take the SAPE arm now, or we're going to touch this inner plane, which where I would want my first sticky weight to go, and I'm going to touch the second outer plane where I want the second sticky weight to go. This is ALU2 plane. We have our first sticky on the inside. Machines automatically captured that data. In the event that I wanted to do a nail on, I could just touch the nail on spot and then again the sticky on the inside plane, and then the machine obviously sees that dip in location at that second data point, and so it automatically knows we have a clip-on weight on the inside and a sticky weight on the outside. After you've put those two dimensions in, you're simply going to close the hood and allow it to do its initial spin. This is the point at which we can see that really short cycle, 6-second initial spin, super fast. We got a small wheel, it's only calling for a 1/2 ounce of weight on the inside. We call this stop on top. It's gonna stop extremely close to one of the weight planes. It may be the inside, it may be the outside, it's just whatever the RPM of the machine's clutching down to. And on this inside plane where it is stopped at top, wants me to nail on a 1/2 ounce weight. Nail on weights are always gonna go at 12 o'clock, no matter what machine you're using. However, the sticky weight on the inside plane, although there's no weight being displayed here, I can still land its location. If I hit F3, it'll give me the residual amount, which is 1/10 of an ounce. I can take my sape arm at that point. Let's say that was a quarter, that was a half, whatever. Take my sape arm. I'm gonna simply take the weight that I have selected. I'm gonna grab a 1/2 ounce off of this strip. I'm gonna take the adhesive backing off of it, insert it into the sape arm. Its spring-loaded collar pulls back, and then with this plane highlighted in green, as I pull this arm out, you're going to see this index countdown. It's going down all the way to 0. Once it zeroes out, it'll beep at me, just like so. And at that point, what I'm going to do is I'm going to depress the little trigger applicator here, and that's simply going to apply the weight exactly where I told the machine I want the counterweight to go. This is one of those areas of confusion when people are trying to cross over brands or use other user interface, because we may either go to 12 o'clock here or 6 o'clock here, depending on our experiences with other pieces of equipment. But the beauty of the sape arm is it's not allowing for that user error. It's making me apply the weight exactly where I told the machine I want the weight to go. So if I look at this from a side perspective, I'm looking at the weight is actually going more at the 11 o'clock range. And that's simply because this is only a 15-inch rim. If this was a 22-inch rim, I might be applying the weight at 1 o'clock range. The point is, it's never right at 12. So if I actually apply this weight at 12 o'clock, what I know is gonna happen is when I do my check spin, it's gonna say, you need to add a little weight. You need to add a little weight. That's what we call chasing weight. And chasing weight is almost always due to one of two things: mounting inaccuracies or data capture inaccuracies. That will eliminate a big part of some folks' frustration. It also speeds things up in the shop. Although we have a very small footprint entry-level balancer here, it's not touchscreen. We do have the buttons here still on the 7200S, which stands for standard. We have a lot of capability here to be quite quick. So the throughput on this machine is very fast. We still have the ability to switch between static and dynamic or single and 2-plane modes. So if I wanted to just put on a sticky weight and take care of this residual static imbalance only on this wheel, I can take this 3/4 of an ounce and apply it. In the event that I want to add only to take care of a static or a single plane imbalance, I'll take this and put it at 12 o'clock, and here and only here during a static is where you apply weight with a sticky or a nail on at 12 o'clock. You'll never use the sape arm to apply weight during a static balance. So it's always gonna be at 12 o'clock. The reason for that is because we're not taking care of the shimmy in this assembly. We're literally only taking care of the vertical, and that vertical could be done anywhere on this line at 12 o'clock. So if I choose to add all 3/4 of an ounce on the inside, I'm gonna take care of the static balance, of course at the expense of adding dynamic instability. So it would be important for me to say, maybe I wanna do 1/2 and 1/4, or in the case of sticky, I'd put all 3/4 right in the middle. If this was an even 1 ounce, you'd wanna split it and go 1/2 and 1/2, something like that, depending on what type of weight application you're doing. But that's often gonna give you the best result. So although we have, again, entry-level machine, our capability is still quite high. We can even go one step further, and in a dynamic situation, if I wanted to maybe this was a little bit larger of a wheel assembly, I wanted to hide some weight behind this guy, I could simply touch F1 and tell this that this was a 5 or a 6 spoke assembly. I'll take a spoke, put it right at 12 o'clock, so I have a spoke at 12 o'clock, and then I'll hit the F5 button, which is split weight mode. Now what it's done is it's taken the pie and it's put 5 spokes in there. So when I go to put my weight in here and apply my weight, it's going to be right behind a spoke, so I don't have to look at, you know, 2 ounces of stick-on weight, maybe in this 20-inch 5-spoke wheel. It's got a lot of real estate, nice black wheel, and I got this gray 4 or 5 ounces of weight sitting on the inside plane. It doesn't look so good. So a lot of features packed into a smaller package, a little bit less intuitive having the buttons and not the touchscreen, but actually very, very easy to use. 115 volt small cabinet, everything works great. Comes with a standard smaller weight tray and a standard set of 3 cones. Why does it come with cones and it doesn't come with all the other tooling? Well, tooling's global, right? So if I was going to tool up for everything, I might have to invest in a rather large amount of tooling, whereas every car for the most part comes with a spare tire. Kind of the same thought process with the balancers and the cones. They come with a few cones so that they can get somebody off to the races with an initial set going, steel wheels and stuff like that, where they're acceptable to use. That sums it up for today. Thanks for hanging. We'll catch you guys on the next one.